In this video, we will talk about the predict command in Splunk. Now, predict command is a very interesting and useful command in Splunk for future prediction. So we will try to see different stuff about the predict command today. So generally for the predict command, so this is the functionality wise, this is the stuff it can do. So basically the predict command forecast the values for one or more time series data. So basically we'll be dealing with the time series data, then we can use the predict command for future production or forecasting purpose. Okay, now it can provide the prediction for several time steps. That means, let's say if you want to predict for next 30 days or 30 months, you can do that using predict command as well. So there are certain configurations which we will be discussing as well today. So that also it can do. And it also provides the confidence level, confidence intervals for all of its estimates. We will see that one as well today. Now, one of the important stuff, as we can see it over here, is the time series, which basically we'll be dealing with when we'll be dealing with the predict command, correct? So let us talk briefly about time series, because these concepts are important when we'll be working with predict command, and we will try to touch base important concepts today regarding time series, and then maybe we will move on to a small demo of the predict command. Now, what is time series basically? So time series is a series of data points for different, like, equally spaced points in time. So let's say like let's say Apple stock price from, let's say from 2018 to till today. So if everyday stock price, we just list it out, and or we can, if we just can graph it in Excel or in any graphing tool, so we will get a time chart, right? So that is nothing but a time series data over here. So that means we will be taking some observations or measurement for times which are equally spaced. Equally spaced means, like, let's say if we are taking that observation or measurement every second or every hour or every minute, something like that. Okay, so we will get a time series data. Now, regarding the time series, when we talk about time series, basically we generally need to understand the time series components as well. Now, there are very much important components of time series, so let us analyze them. So broadly, we can divide them as systematic component and non-systematic component. Now, systematic components are those characteristics of the time series which we can easily model, or which is basically deterministic in nature, or that particular component can be described easily. So, and non-systematic components are those components which are random in nature, okay, and those cannot be modeled correctly. Now, systematic models or systematic components are basically the level, the trend, and the seasonality of the time series. Now, and the non-systematic components are basically the noise of the time series, like unusual, those we can say like the outliers of the time series basically. So what do we mean by this label, trend, and seasonality of the time series? Now, label means like the average value. So let's say like every seconds we are measuring the temperature of a room, right? Now, for all the measurement we did for, let's say, past couple of days, if we just take the average of it, so that is nothing but the level of the time series. Now, the trend is basically, it can show basically the general direction of the time series, like whether the time series is ever increasing or decreasing of the values of the time series. So that means it's the general direction of the time series is called the trend of the time series. And seasonality means like it's a repeating short-term cycles in the time series. So let's say like every New Year or during Christmas, the sales volume increases, right? So this can be a seasonality factor. That means it repeats every year and during that period only. Okay, we'll see the data today as well, some of the data which is seasonal in nature as well. So from there maybe we will get better idea about that one when we will see the data. and noise means it's just the random variation in the series. So certain very high increase in the temperature or decrease in the temperature, if we are just talking about measuring the room temperature over there. Okay, so we got an idea about what the different components of the time series. So if we just give an example of them, so if you see this particular time series, it was like a increasing, right, ever increasing time series. But if you see, like, there are certain points it was dropping drastically or it was increasing drastically as well. So this random decreasing or increasing we can thought of as noise in the time series. And if you see this data, and if you see, like, there is a certain pattern over here, right? So from this point to this point it was increasing and then it was decreasing again, it started increasing to this point and then again it is decreasing from here, right? So there is a pattern in the data and which is repeating as well. So this is called the cycle, right? So this cycle is repeating over here, correct? So this is called the seasonal pattern in the time series. Okay, and if you see this one, if you see, there is a seasonal pattern over here as well, like this particular stuff is repeating, but the time series also increasing over here. So from the first cycle, the second cycle is repeating in the same nature, but it is having the higher value as well over here. Okay, so this is called the trend. Basically the time series is increasing over here with the seasonal pattern over here as well. Okay, so these are all the time series component. Now when we talk about the time series analysis, there are certain two things as well we need to understand, is called the univariate and the multivariate time series analysis. Now these concepts are very similar or very easy to understand, but maybe when I will be developing that statistics for data science playlist, over there maybe we will touch base these concepts again to go in deeper. But for this video, I think if we understand it in single line, it should be sufficient enough. So univariate means only one variable is varying over time. So let's say we are collecting temperature from a sensor in our room every second. So therefore every second the temperature is only changing over here. So that means you will be only having a one-dimensional value, which is the temperature is changing over here. So this is nothing but a univariate time series. Okay, in contrast, multivariate time series means there will be more than one variable which will be changing over here. So let's say if we talk about a triaxial accelerometer, right? So there will be 3 accelerations over there for each axis, x, y and z axis. So that means for these 3 accelerations are changing simultaneously over the time. So that means if we just take the measurement of this acceleration for every second or every minute, we will be measuring basically the acceleration along the x-axis, acceleration along y-axis and z-axis. That means there will be 3 variables which are changing simultaneously, right? So this is nothing but a multivariate time series. But why we discuss this one? Because in the predict command we will see a lot of algorithms. So some of the algorithms will be working on the univariate time series and some of it will be working on this multivariate or bivariate time series over here. Okay, so with this brief concept, so let us go to Splunk and try to see how predict command works. Okay, the data today we'll be using for our analysis is the power usage data from 2016 to 2020 I think in Houston. So you can download this particular data from Kaggle. So I have downloaded this one and I have indexed the data as well. So there are 2 time series data. One is the power usage, which is univariate in nature, and there is a weather data as well, which is multivariate in nature as well. Okay, now if you just see the power usage data, it is a very simple data set. Actually, we have a date field, basically the time field, and the power in kilowatt hour and the days of week and some notes over here. Now notes means whether it's a weekday or weekend, something like that one. Now for our analysis we will be mainly using 2 columns, the date column and the power usage value in kilowatt hour. Now if I just show you the same data I have indexed as well in my main index, and this is how it getting indexed. So as I said, we will be using two fields. One is the underscore time field, if you see it, and the power usage over here. Now for the predict command, as it is a time series data, so the first thing you need to understand is you need to convert your data as a time series data first, okay? And the only way we can do it is using a time chart. So the first thing we'll be doing is we will be using a time chart over here. Now time chart, now as this particular data has been taken every day, so what we'll be doing is we'll be doing a monthly analysis, okay? So that's why I'll be writing span equals to 1 month, and I will be taking the average value of the kilowatt hour, okay? So this one, so if I show you over here, so this is the kilowatt hour field name, so that's why I am taking average of that particular field name as value over here. So this will be my time chart value, okay? So if I just go to the visualization and select it as a column chart, it will make more sense. If you see it over here, let us first analyze this particular data, then we will be using the predict command, okay? Now if you see, this particular data has some kind of seasonality. That means if you see like around May, June, and then July, the usage, the power usage is actually more than whenever we're moving to August, September, it is little bit in the lower side because this is the peak summer season, correct? And if you see like every year it is happening something like this one, May, June, July, and then from August onwards it is decreasing over here, okay? And if you see like for 2016, this was also there, like in May, June, July also this was there, but the data value was little bit on the higher side. But once we moving to from 2016 to 2020, so that it has this particular seasonality, but the average values are actually little bit on the lower side, okay? That is the information at least we are getting visually from this particular time series data. Now let us try to predict some future values based on this particular data, okay? So as I said, we will be using the command called predict. Now for the predict command, you need to give the field names which you want to basically predict. Over here we have only single field called value because I have renamed this average value as val, so I'll be giving the field name called val over here. Now here, if you have multiple time series data, you can give multiple field names over here as well. And if you want to, okay, let's see it first, then I will show you that as clause as well. So predict command, then the field we want to predict. Now the second thing is the algorithm, okay? You need to use it over here. Algorithm, if you see, there are a lot of algorithms are available. Now which one to use? We will start with local level, okay? Now in our PPT we have seen the label of the time series is basically the average value of this particular, all the data points of a particular time series, correct? So this local level is also do the same stuff. It basically calculates the average value of all the data points we have in our time series, okay? Now if I just go to the Splunk documentation, this is important. Whenever you will be using any particular algorithm, whether it's a LL or LLT or whatever, you need to keep in mind that there is a requirement of how many minimum data points you need. For local level, at least you need 2 data points. That means at least you need 2 values to predict something over here, okay? We have more than 2 values over here, that's why we can use the local level over here, okay? So now we have given the local level algorithm. Now this is sufficient enough for the prediction, okay? So if I just run this one, so let's see how it predicts something. If you see it, so this is the 3 line, basically it has created over here. So for existing values, it is try to go through it and try to model it, and the upper values and lower values are the upper 95 percentile and the lower 95 percentile values over here, prediction values. As I was showing in my first slide, like apart from the actual prediction, it also calculates the upper percentile and the lower percentile as well. Okay, now if you see, it has by default it has predicted for 5 months because that's the default value it predicts. So now if you want to do it for more than 5 months, so there is a input called, if I just go back over here, is the future timestamp over here. Okay, so we will be using this one. At least we will try to predict for, let's say, next 30 months. We will see how it goes over here. Okay, now if you see, now it is predicting for next 30 months, but we can see from our data that there is a seasonality over here. Like during peak summer, our power usage are more compared to the winter season, correct? But as we have used the algorithm called local label, which only calculates the average, so it kinds of calculating only the average, a fixed value over here. Okay, so that is what the local level algorithm does. It just calculates the average over here. It does not take into consideration any trend or any seasonality factor in the time series. Okay, so that's the first algorithm we discussed. Now I'll keep this one so that we can compare. So I will open a new search over here. I will copy this one and I will paste it over here. I'll do it for all time. First I'll run it for LL only. Now, okay, let me show you another stuff over here. Is, if you see, if I just go to the statistics tab, so the field it has created is for lower 95 percentile, the actual prediction of the value, and the upper 95 percentile. If you want, you can rename this field as well over here. So if you just want like prediction val, if you want something like prediction underscore val, so you can give a as clause over here, prediction underscore val. So it will be creating the field called prediction underscore val over here. I will show you how to rename these guys as well in latter part of this video. Okay, so we talked about the LL algorithm. Now let's move on. Let's talk about another algorithm called LLT. So as the name suggests, it is the local label trend, if you see it, correct? So this is also a univariate time model. So we talked about the univariate and the multivariate time series analysis in my PPT as well. It only considers the trend. It does not consider any kind of seasonality. Okay, and it requires minimum 3 data points over here. This is also important. So let us see how it works. So instead of LL, we will be giving LLT, local label trend over here. I will keep the future timestamp as 30. So I will go to visualization tab. I will now run it. Okay, now see it. One interesting factor is coming up for local label. If I just go to the visualization, it kinds of calculating the average. That's why all those values are same actually over here throughout this future timestamp, correct? But if you see it over here, because it considers the trend, and when we initially saw our data set, like during 2016, the power usage was more compared to when we were moving to 2020, correct? So that's why this time series is actually having a decreasing trend, which is actually able to capture it over here as well, if you see it, correct? So over here, if you see it, like initially it was like higher values, then it's moving to the lower values as well over here for future timestamp as well. And for this one also, it predicts the upper 95 and lower 95 percentile values as well. So this is the LLT algorithm, which basically considers only the trend, but it does not consider the seasonality. But if you see it, like this is also not a good prediction for our data, because our data is having a seasonal factor as well over here, correct? So the reason behind I am showing you different algorithm for the same data is based on your data you need to determine which algorithm works best over here, and also what are the stuff you need from this prediction over here as well. Okay, so let us move on to the next algorithm. The next command we'll be talking about is the LLP, which is basically the seasonal local level. That means it only considers the seasonality of it. Okay, it does not consider the trend, it only considers the seasonality. Now here the important factor is the number of data points must be at least twice the number of periods over here. Okay, so that means period means like if I just go to our data over here, so the cycle where it is where it is basically repeating. So in this case, at least we can think of the period as 12 months, because that's the cycle it is repeating over here as a seasonality pattern over here. Okay, now when we'll be using, so let me open a new search window over here, similar way, so that we can compare it as well. I will do it for all time. So this is for our LLT, right? So now visualization, now we will be using the LLP over here. Okay, so as I said, so this is only considering the seasonality of the data. It does not consider any trend over here. So if I just run this one now, so if you see it over here, now the output is getting changed over here. So it is actually considering all those seasonality factor, like during the May, June, it is our future prediction is also getting increased, and whenever we are moving from July to August and September, it is getting decreased as well, and it is repeating again like this one for future 30 months over here. Okay, but if you see it as our time series has also a trend factor, like it is decreasing trend, but it does not show any decreasing trend over here. If you see it, like it is getting almost giving us like wherever we have started the similar value over here, correct? So this is the LLP algorithm. Now over here, as we said, there is a period factor, correct? Because this is a seasonality, because this is taken into consider the seasonality. Now if you know the period, you can give the period as input as period. Otherwise it tries to calculate the period value from this data itself. Okay, so anyway, if you are confident about the period, you can do that. Otherwise you can leave it to this algorithm to determine the period automatically over here, which is, I think it is doing a pretty decent job over here to finding the period and calculating the future values over here. Okay, similarly it also calculates the upper and lower percentile values as well. Now let us talk about the next algorithm called LLP5, which basically consider both the trend and the seasonality as well, which could be the better algorithm in our case as well, because we have a trend and as well as seasonality in our data as well. So let us do that one. So I will just duplicate this one. Okay, now if I just go back to the documentation again, so LLP5 basically combines this LLT and LLP algorithms together, and it basically calculates the weightage average of the trend and the seasonality over here. Okay, and even the confidence interval also, it calculates the weightage average over here. Okay, so if I just go back over here, instead of LLP, use the LLP5 and run this algorithm over here, and now if you see it, like it also considering the seasonality factor over here and also calculating the trend value over here. And if you see, like the trend value is minimum side, the future values are actually minimum side over here as well, compared to this one where it was predicting almost 1.2 for May 31st. Here it is calculating around 0.9 for the May 31st over here. Okay, so this could be the better algorithm in this particular data set over here. So the LLP5, which takes into consideration both the trend as well as the seasonality over here. Okay, now we talked about like the univariate models over here a little bit. Now let me give you certain inputs of this predict command. So let's say there is a input called holdback. Okay, so if I just give holdback equals to 6, that means for the last 6 months it will not take into consideration that particular data. So it will basically hold back that particular data and it takes rest of the data into prediction purpose. Okay, so that also you can do. So let's say if you do not want to take into consideration this last 6 months of data, so then in that case you can give the holdback, and then for rest of the data it will do certain kind of prediction over here. If you see, if this prediction is little bit different compared to whatever it does without the holdback over here, okay. So this is the holdback. Now let me show you the confidence interval level. So by default it basically predicts the 95% confidence interval level. So you can change that as well using lower int and the upper int value over here. Okay, so this two stuff. Now by default, as I said, it is calculating 95% confidence level. So you can do it for 90th as well. In that case, after lower you need to give 90, and you can give the name of the field as well. So currently if you see it, for 95% confidence level it was creating a field name called lower 95 then prediction val. So you can give some name, let's say lower 90 underscore predict. So what it will be doing, it will be creating a field called lower 90 underscore predict, then in the bracket prediction val. Similarly for upper as well, we can do the same stuff, 90, and I can give upper 90 underscore predict over here. So it will be creating those fields accordingly over here. If you see it, like for the now it is calculating the 90th percentage confidence level, and if you see the field it is creating is that only whichever we have given it over there, similar stuff. Okay, so this is the two inputs for predict command as well. Now let's talk about a bit about the bivariate model. So we will be talking about a algorithm called BIL over here, which is basically used for predicting the multiple time series value, multivariate time series value. Now for that we have another data set. So let me go back to our main index for all time. So if I just go to Kaggle, so there is another data set called weather data set, so which is nothing but the multivariate data set, because for the time it has the temperature field, temperature max, mean and average, and it also has other fields like the dew and other stuff. So let me go back over here. If you see the dew max, mean, something, humidity as well. Okay, so the same data I have indexed as the source, weather data source, and if you see it, like we have dew, humidity, temperature, those stuff. So we will be mainly working with two values over here. So similar way, I will be doing the time chart first, and then I will be using the predict command over here. So let's say if I will be doing for 1 month only, span average of the time temperature average as average temperature and dew average as well for that particular month. Okay, so if I just run it and go to visualization, so this is how it looks like, and if you see it, like it also have some kind of seasonality over here as well, correct? Now if I just want to predict this two time series over here, if you see there are two time series over here, one is the average temperature and another is the average dew. So we can use the algorithm called ALGORITHM algorithm called BIL over here to predict multiple time series over here. So the average temperature and the average dew over here. Okay, so if I just run it, so now it is basically, if you see it, it is predicting the average temperature as well as average dew over here as well, but looks like it does not taken into consideration. So if I just give future future time span as 30 as well over here, so that you can see a longer future values over here. And if you see, it does not take into consideration of the seasonality factor over here. So this is a very basic algorithm over here. Now here one input you can use called suppress. So if you have so many time series you are predicting, and for easy viewing purpose you want to omit, or you do not want to display some of it, you can use this suppress as well. So let's say I do not want to see the average dew, I just wanted to see the average temperature over here. I can use the suppress as well over here to suppress all the calculations related to the dew over here. If you see, currently it is only showing the prediction for the average temperature over here. Okay, so that is the suppress input over here. But generally I think this particular command is useful for the trend and seasonality, that LLP5 algorithm over here. It does not take into consideration, it does not have good output for multiple time series over here. Okay, so hopefully we got a good idea about the predict command and its different shortcomings and advantages as well. Okay, so according to your data, basically you need to choose the proper algorithm and then use the predict command as well over here. Okay, so hopefully this video was helpful. See you in the next video.